Today we will learn about Unit 5, Periodic Classification of the Elements. The main contents of Unit 5 are historical development of the periodic classification of the elements, Mendeleev's periodic classification, and the modern periodic table. In this unit, you will be able to narrate the historical development of periodic classification of elements, state Mendeleev's periodic law, discuss the contributions and shortcomings of his periodic classification of elements, and state the modern periodic law. Explain the relationship between the electronic configuration of the atoms and arrangement of the elements in the periodic table. Explain the structure of the modern periodic table. Describe the trends in nuclear charge, atomic size, metallic and non-metallic character of elements across a period and down a group of the modern periodic table. Appreciate the importance of periodic classification of elements. But first, a historical note. Dmitri Mendeleev has made the most successful. Subunit 1, the historical development of the periodic classification of the elements. By the end of this subunit, you will be able to narrate the historical development of periodic classification of elements. Who proposed the law of triad? Dobereiner arranged similar elements in a group of 3, or triads, in the increasing order of their atomic masses. He observed that the atomic mass of the middle element is nearly equal to the average atomic masses of the other 2 elements. For example, the atomic mass of sodium is equal to the average mass of lithium and potassium. Who proposed the law of octave? John Newlands proposed the law of octave, or the law of 8. He said the 8th element has similar properties to the first one. This is similar to the musical octave, where all the notes repeat each other in different octaves. The law of octaves could be applied only for elements that were known at the time and failed for elements beyond calcium. In summary, Dobereiner and Newlands' classification of elements were the early attempt in classifying the elements. The law of triads was attempted by Dobereiner. The law of octaves, or the law of 8, was proposed by John Newlands. In review, who is the scientist that proposed the law of octaves? John Newlands. What makes the law of triads and law of octaves similar? They arrange elements in the order of increasing atomic mass. Subunit 2, Mendeleev's periodic classification. By the end of this subunit, you will be able to describe periodicity, state Mendeleev's periodic law, and discuss the contribution and shortcomings of Mendeleev's periodic classification of elements. In Mendeleev's periodic classification, the properties of elements are periodic functions of their atomic masses. That means the properties repeat. Here is part of Mendeleev's periodic table. What were the shortcomings of Mendeleev's classification? Some of his elements were actually in the wrong order, and there was no separate place for isotopes. In summary, Mendeleev's periodic law states that the properties of elements are periodic functions of their atomic masses. The main achievements of Mendeleev's is that he grouped the elements more accurately based on their properties, and he made a bold prediction of the existence of undiscovered elements and left gaps for them in his periodic table. How did Mendeleev organize the elements into the periodic table? Mendeleev arranged the elements according to increased atomic mass. What important relationship did Mendeleev observe between elements in a given group? Elements in a given group exhibit similar physical and chemical properties. Subunit 3, the modern periodic table. By the end of this section, you will be able to state the modern periodic law, define period and group, tell the total number of periods and groups in the modern periodic table, determine the period and group numbers of some elements based on their atomic numbers, describe the relationship between the number of periods and the number of main shells in an atom, tell the total number of elements in each period of the periodic table. Describe the relationship between the number of groups and the valence electrons of the atoms. Write the names of each main group of the elements in the periodic table. Describe the variation of atomic size, nuclear charge, metallic and non-metallic character of elements across the period, and describe the variation of atomic size, nuclear charge, metallic and non-metallic character of elements down the group. In the modern periodic table, the properties of elements are periodic functions of their atomic numbers. They go in increasing order of atomic number. This means elements are arranged in the increasing order of their atomic numbers. Therefore, elements having similar properties will fall in the same group and column. In the modern periodic table, the elements are classified into periods and groups. What are the periods? They are the horizontal rows in the periodic table. There are 7 periods of elements in the modern periodic table. Period 1 contains 2 elements. Period 2 contains 8 elements. Period 3 contains 8 elements. Period 4 contains 18 elements. Period 5 contains 18 elements. Period 6 contains 32 elements. And period 7 is a recently completed period. Here are 2 examples of periods, period 2 and period 3. They are the horizontal rows of the periodic table. What are the groups? They are the vertical columns. There are 18 vertical columns in the periodic table. For example, the first group is on the left of this figure. The second group is on the right of this figure. The group number of an element is equal to the number of its valence electrons. So in group 1, there is one valence electron. In group 2, there are 2 valence electrons, and so on. There are group A elements and group B elements. Group A elements are called representative elements or main group elements. Group B elements are called transition elements or transition metals. What are the common names of representative elements? The common names are, in group 1, the alkali metals. Group 2, alkaline earth metals. Group 3, the boron family. Group 4, the carbon family. Group 5, the nitrogen family. Group 6, the oxygen family. Group 7, the halogens. And Group 8, the noble gases. There are many trends across the period and within a group. For example, if we move across the period from left to right, nonmetallic character, electronegativity, ionization energy, electron affinity increases. However, atomic size or atomic radius and metallic character decreases. If we move down a group, metallic character and atomic size increases. However, ionization energy and electronegativity decreases. What are the periodic properties of the elements in the periodic table? The properties are nuclear charge, or the total charge of protons in the nucleus of an atom. Generally, nuclear charge increases as more protons are added to an atom. Since the elements are arranged in the periodic table according to increasing atomic numbers, nuclear charge increases from the left to the right across a period. In going down a given group in the periodic table, the nuclear charge increases due to the increase in the number of protons in the nucleus. Atomic size, or atomic radius. This is the distance from the nucleus to the outermost shell of an atom. Atomic size decreases in going from left to right across a period. This is because a period, the number of protons in the nucleus increases. But electrons are being added to the same shell of the atom. These electrons are more strongly attracted towards the nucleus by a progressively higher positive nuclear charge, as I mentioned in the first point. As a result of this, atomic size decreases. Metallic character are metals that are found on the left side of the periodic table. Nonmetallic character, electronegativity. This is a property of an atom which increases with its tendency to attract the electrons of a bond. Ionization energy is the energy required to remove an electron from a gaseous atom or ion. Electron affinity, the ability of an atom to accept an electron. In summary, the modern periodic law states that the properties of elements are periodic functions of their atomic numbers. The group is the vertical column of elements. The period is the horizontal row of elements. The periodic table consists of 8 main groups and 7 periods. All elements in the same group have the same number of valence electrons. The number of valence electrons determines the group number of an element in main group elements. The number of shells of an atom equals the period number to which the element belongs. Metals are found on the left side, while nonmetals are found on the right side of the periodic table. Periodic properties of elements, such as atomic size, nuclear charge, and metallic and nonmetallic character, vary across a period and down a group. In review, all elements in the same period have the same atomic number, physical properties, number of shells, or number of valence electrons. Number of shells. The common name of group 7 elements is noble gases, chalcogens, halogens, or alkaline earth metals. Halogens. Across a period, atomic size of the elements decreases, increases, increases and decreases, or remains the same. Decreases. How many elements are there in the third period of the periodic table? 8, 18, 4, or 32? 8. Which of the following increases both down a group and across a period in the periodic table? Valence electrons, nuclear charge, atomic radius, or metallic character? Nuclear charge. An element with atomic number 10 is found in Group 7A and period 8, Group 6A and period 2, Group 2A and period 3, Group 8A and period 2, Group 8A and period 2. Which of the following is the shortcoming of Mendeleev's periodic table? Elements were arranged by their atomic mass. Some elements were not placed in their exact position. Gaps were left for some undiscovered elements. It helped for the discovery of new elements. The shortcoming of Mendeleev's periodic table were he did not give a separate place for isotopes. Some elements were arranged in a wrong order. So the answer is B. Some elements were not placed in the exact position. In the modern periodic table, properties of elements are periodic functions of their atomic mass, atomic number, atomic size, mass number. The modern periodic table states the properties of the elements are periodic function of their atomic number. The answer is B, atomic number. An element has the electron configuration 2, 8, 7. The element is found in period 3, group 7, period 7, Group 3. Period 2, Group 1. Period 4, Group 2. To determine the group and period for an element with the electron configuration 287, use the following method. The group is the number of valence electrons. That's 7. The period is the number of shells. That's 3. The answer is A, period 3, group 7. Which of the following is expected to have the highest atomic radius? Beryllium, boron, lithium, or nitrogen? When they are arranged in increasing order of their atomic number, lithium, beryllium, boron, and nitrogen. All are found in period 2. Across a period from left to right, atomic radius decreases. This means lithium has the highest atomic radius than the rest of the elements. The answer is C. How many elements are there in the third period of the modern periodic table? 2, 18, 8, or 32? In the modern periodic table, period 1 contains 2 elements, hydrogen and helium. Period 2 contains 8 elements, from lithium to neon. Period 3 contains 8 elements, from sodium to argon. Period 4 contains 18 elements, from potassium to krypton. Period 5 contains 18 elements. Period 6 contains 32 elements. Period 7 is a recently completed period. The answer is C, 8. Group 7A elements are called halogens, chalcogens, alkyl metals, or alkaline earth metals. Group 1A is called alkyl metals. Group 2A is alkaline earth metals. Group 3A is the boron family. Group 4A is the carbon family. Group 5A is the nitrogen family. Group 6A is the oxygen family. Group 7A is the halogens. And Group 8A are the noble gases. The answer is A, halogens. An element with an electron configuration of 2, 8, 2 belongs to Group 3A, period 2, period 4, or Group 2A. To determine the group and period for an element with the electron configuration of 2, 8, 2, use the following method. The group is the number of valence electrons, 2A. The period is the number of shells, 3. The answer is D, Group 2A. Which of the following decreases down a group in the periodic table? Nuclear charge, nonmetallic character, metallic character, or atomic size? Atomic size, Nuclear charge, a metallic character, increases down a group. Non-metallic character decreases down a group. The answer is B, non-metallic character. Which of the following is true about nuclear charge in the modern periodic table? Decreases from left to right and increases from top to bottom. Increases from left to right and decreases from top to bottom. Decreases from left to right and from top to bottom. Increases from left to right and from top to bottom. Nuclear charge is the total number of positive charge in the nucleus. It increases down from top to bottom of a group. It increases across from left to right of a period. The answer is D, increases from left to right and from top to bottom. The position of an element with atomic number 15 in the periodic table is Group IIIA in period 3, Group IIIA in period 4, Group VIIA in period 3, Group VIIA in period 2. Electron configuration is 2, 8, 5. The group is the number of valence electrons, 5. The period is the number of shells, 3. The answer is D, Group VIIA in period 3. Which of the following represents the electronic configuration of the elements in the same period of the periodic table? A, 2, 4, 2, 6, and 2, 8. B, 2, 5, 2, 8, 2, or 2, 7. C, 2, 1, 2, 8, or 2, 8, 1. D, 2, 7, 2, 8, 1, and 2, 5. Elements in the same period have the same number of shells. Thus, the electron configuration in choice A has the same number of shells, 2 shells. The answer is A. Which of the following statements is false about the modern atomic theory? Elements are arranged in the order of increasing atomic masses. The properties of elements are periodic functions of their atomic numbers. Elements having similar properties will fall in the same column. Elements are arranged in the order of increasing atomic number. Choices B, C, and D are true statements about modern atomic theory, but choice A is a wrong statement. The answer is A. To which period does an element with atomic number 14 belong? 5, 3, 2, or 6? To determine the period and group, write the electron configuration. 2, 8, 4. The period is the number of shells, or 3. The answer is B, 3. Which of the following elements is present in a group 6 in the periodic table of elements? Boron, phosphorus, chlorine, or sulfur? To determine the group, write the electron configuration for each element. For boron, it's 2, 3. For phosphorus, it's 2, 8, 5. For chlorine, it's 2, 8, 7. For sulfur, it's 2, 8, 6. The group is the number of valence electrons, 6. Sulfur. The answer is D, sulfur. Which of the following is not the advantage of the modern periodic table? The periodic table is useful in predicting the properties of elements. The periodic table is useful in predicting the color of elements. The periodic table is useful to predict new elements. From the periodic table, you can read, deduce, and state basic information about a given element. The periodic table is useful in predicting the properties of elements. The periodic table is useful to predict new elements. From the periodic table, you can read, deduce, and state basic information about a given element. Choice B is not the advantage of the periodic table. The answer is B. The periodic table is useful in predicting the color of elements. An element with atomic number 18 is found in Group 6A and period 3, Group 6A and period 4, Group 8A and period 3, Group 8A and period 4. To determine the group and period of an element with atomic number 18, write the electron configuration. 2, 8, 8. It has 8 valence electrons, so it's found in group 8. And it has 3 energy levels, so it is found in period 3. The answer is C, group 8A and period 3.